Friday, we were talking about we're still in logarithms. Logarithms and exponents, exponential functions going together. And Friday we talked about if we had a single logarithm, how we could expand it. We talked about expanding something, it's getting bigger, and how we took one single logarithm function and expanded it into two or more different log functions. And so for instance, if we had, this is what we did Friday, if we have log base 2 of, let's say, 5x divided by y, okay? Log base 2 of 5x divided by y. We asked, how many factors do we have in this function? And we said 1, 2, we said 3. So therefore, how many logs am I going to end up with after I expand this? You guys said 3. That's perfect. So 3, every log is going to have the same base, and these factors are going to be separated by pluses or minuses depending upon if it's multiplication or if it's division. So I start out with log base 2 of 5. 5 is being multiplied by x. So multiplication means what when I'm expanding? Addition. Multiplication means addition. So I get my second log in there. So log base 2 of x. And then y is being divided, and in when I'm expanding logs, division means subtraction. And so then I am able to write my last log. So I have 1, 2, 3 logs because I had 1, 2, 3 factors. The 2 factors that are being multiplied in the numerator get a plus sign, and the 1 factor that's being divided that's in the denominator gets the subtraction sign ahead of it. Okay? That's Friday's work. Now, one thing we didn't talk about is what if I had this, log base 2 of x cubed. Where did I write this exponent? What happened to this exponent? It went out in front because a power being raised to a power back with our rules of exponents meant multiplication. So when that comes out in front, I get 3 log base 2 of x, which in essence means 3 times log base 2 of x. Okay? So we had an addition, which is called the product rule. We had subtraction, which is called the quotient rule. And then we had the power, which we, something being raised as an exponent, we call that the power rule that we talked about on Friday, those 3 rules. Okay? So that's Friday. Today, we are actually taking these 3 rules and working them backwards. So we're going to be starting with this part, and we're going to come up with this. We're starting with 2 or more logs, and we're only going to be writing out 1 log. So no new rules, nothing new to learn, to memorize, or anything like that. We're just reversing the process, okay? So we're going to be starting with something out in front being multiplied, and we're going to be writing it as an exponent, okay? So for instance, here's my product property from Friday. Okay, so today, this is how it's going to be starting with the right-hand side, and we're going to the left-hand side. So for instance, if I have log base 2 of 3 plus log base 2 of x, this is just an example. If I have log base 2 of 3 plus log base 2 of x, I know I'm going to only write 1 log. So I'm just going to go ahead and write that down. Log base 2, because the bases have to be the same or this doesn't work. And in the log properties, addition means what? Multiplication. So this addition sign means multiplication. And what am I multiplying? 3 and the x. Okay? All right, now let's look at the quotient. And we're going to be doing a ton of these. Well, okay, not a ton, that's an exaggeration. But we're going to be doing quite a few of these, and I think by the end of this sheet, you know, you'll start getting the hang of it. Quotient. Let's say I've got log base, let's change the base to 5. Let's say I've got log base 5 of 7 minus log base 5 of 9. All right, so I know that I'm going to condense it. So the directions would say condense this expression. So I know I'm going to condense it down to 1 log base 5. Subtraction means division. So I'm going to, this means division. And so I'm going to divide the 7 and the 9. And if it's helpful that when you go and you're writing that 1 log, if you just cross off that log, what's left is what you're either multiplying or dividing. Okay? If that's helpful to you. The last one is my power property. Let's say I start with 2 times log x. There's no base on my log, so we call that the common log because it's an assumed 10. And since that 2's out in front, I know that I'm going to be using the power property. So log, I use my log, so I'll cross that off and I get x squared because the 2 goes on top. Okay? So really, everything we're doing is exactly what we did Friday, just in reverse. Just in reverse. Okay, so let's work through these examples. Let me know if I'm still on the screen. Let's start with number 1. How many logs do I have? Very simple question. I have 2 logs, okay? So I'm going to write log base 5. And so if I want, I can just cross those off. Subtraction means division, which is 8 over 2. And so that is exactly 12. You're exactly right. I missed the 1. So that's exactly what we're doing. Okay? Now, it does get a little bit more complicated when we have more than just more than 2 logs. Now, can we reduce 8/12? Divide both numerator and denominator by 4, and that reduces down to 2/3. Okay? All right, let's look at number 2. I have 2 times log x plus log 5. This looks like a common log to me because there's no base, so we assume that base to be 10. So I'm going to write that 1 time. I'm going to cross off the logs because I know that I've done that. The plus means multiplication. The 2 out in front means the exponent. That 2 goes out on top of the x, and that's being multiplied by 5. So log x squared times 5. We really don't see it written like that a lot, so let's just clean that up a little bit, even though we won't take off points for that, but that's more like it. We always put the number out in front of the variable. So log 5x squared. Okay, number 3. I have 3 logs, getting a little trickier. So I'm going to write log only 1 time. So get rid of the logs, get rid of the logs, get rid of the logs. The first 2 are being multiplied. So I get 6 x squared. And what's the subtraction mean? Division. It means division. So then that's going to go on the denominator. Okay. Number 4. I have 2 logs. I'm going to only write it 1 time. Oops. Didn't mean to scratch off my x. I was getting a little excited there. So I get 7 squared divided by x to the 5th. 7 squared divided by x to the 5th. What is 7 squared? 49 over x to the 5th. Okay? Number 5. I have 3 logs. I write it 1 time. Cross off those logs. These 2 logs is separated by a plus, so that means they're being multiplied. So I get z y cubed, that 3 is an exponent of the y. The subtraction means division, all divided by x. Number 6, I have 2 logs, get rid of those. So I write the log one time only, x to the 4th divided by y cubed. Number 7. Okay, what's the ln stand for again?
Log in.
Natural log. Okay, natural log is what that stands for. What's the base on my natural log? E. Okay, we assume that to be there. It's not written. So, but we treat it exactly like a logarithm. Okay, same properties apply. So that's 2 to this, that would be a 6, all over y to the 4th. Natural log 2 to the 6th, all divided by y to the 4th. And then number 8, I'm going to have you add on to this. I'm going to say minus log base 4. Let's say log base 4 a plus log base 4 b. Minus log base 4a plus log base 4b. Okay, so we start out, we have 1, 2, 3, 4, 5 logs. Are you kidding me? We get to write all 5 of those logs condensed into 1. So I'm going to cross all the logs that I've used off, and then I'm just going to write what I have left that's not been crossed off. So I've got a 5 and a 2. The 5 gets raised to that 2 as a power, times x to the 7th. The 7th gets raised to that x only, and that 4 gets raised to that y only. And because the a and the b, those logs, are what's preceding that is a subtraction, all of that is being divided by a times b.